TRAPPIST-1 is very different from the Sun that lights up our world. While our Sun is a yellow dwarf star, large, hot, and bright, TRAPPIST-1 is an ultra-cool red dwarf, a much smaller and dimmer kind of star. In fact, TRAPPIST-1 is only about 9% the size of our Sun and has less than 1/10 of its mass. That means if you could place TRAPPIST-1 next to the Sun, it would look tiny, more like a glowing ember than a blazing fire. Its light isn't yellow-white like sunlight. It's a deep reddish-orange, soft but steady, glowing like the last spark of a dying flame. Because it gives off so little light and heat, the area around TRAPPIST-1, where a planet could possibly have liquid water known as the habitable zone, is very close to the star. For comparison, Earth orbits about 150 million kilometers from the Sun, but TRAPPIST-1e orbits its star at a distance of only about 6 million kilometers. That's incredibly close. It's roughly 20 times closer to its star than Mercury is to the Sunday. Yet because TRAPPIST-1 is so faint, that closeness doesn't make the planet scorchingly hot. Instead, it provides just the right balance of energy for potential habitability, warm enough to melt ice, but not so hot that oceans would boil away. TRAPPIST-1e moves so near to its star that it completes a full orbit, what we'd call a year, in only 6.1 Earth days. Imagine that. Every week on Earth would equal an entire year on TRAPPIST-1e. Seasons there would pass in days. A lifetime would contain thousands of years. This fast orbit doesn't mean time actually runs differently. Physics doesn't change that way, but it shows how much tighter and faster the planet's path is around its star compared to ours. Even with this short orbit, TRAPPIST-1e maintains an extraordinary balance. It sits in that narrow Goldilocks zone, the region where a planet isn't too close to the star, where heat would strip away the atmosphere, and not too far, where everything would freeze solid. Welcome to Space-Time Ventures, where the universe tells its stories. Every day we explore the hidden wonders of space, where science meets mystery. Join the mission, hit subscribe, and let's keep pushing the edge of the universe together. It's like walking a tightrope between fire and ice. Scientists find this balance fascinating because it hints that TRAPPIST-1e could have temperatures that allow liquid water. And wherever we find liquid water, we find the potential for life. So the phrase, "a star in the shadows," means two things. First, TRAPPIST-1 itself lives in literal obscurity. It's small, dim, and hidden among the brighter stars of the galaxy. Second, its faintness creates a unique, delicate environment where planets like TRAPPIST-1e can orbit close and yet still remain gentle, temperate worlds. This quiet little red star, sitting in the shadows of the universe, may host one of the best places beyond Earth where life could exist. TRAPPIST-1e is what scientists call a tidally locked planet. This means that one side of the planet always faces its star, while the other side remains forever in darkness. The same thing happens with our moon. We only ever see one side of it from Earth, because the moon takes exactly the same amount of time to rotate once on its axis as it does to orbit around us. The same principle applies to TRAPPIST-1e, only on a planetary scale. Because it's so close to its star, TRAPPIST-1e's gravity and the gravity of TRAPPIST-1 pull on each other strongly. Over millions of years, those gravitational forces caused the planet's rotation to slow down until it became locked in place, one side permanently facing the star, the other eternally turned away. Now, imagine what that would look like. On one hemisphere, it is endless day. The red dwarf star hangs motionless in the sky, never rising, never setting. The sunlight there would not be bright white like ours, but a soft, dim crimson glow that covers everything in a warm reddish hue. Temperatures on this side could be extremely high, hot enough to evaporate shallow seas and dry out rocky plains. The atmosphere would likely swirl with thick clouds as heat drives powerful convection currents upward, creating towering storms that stretch for hundreds of kilometers. On the opposite side lies the eternal night. The star never shines there. the land would be wrapped in unending darkness. Without the warmth of sunlight, this hemisphere could be bitterly cold, possibly hundreds of degrees below freezing. Any atmosphere might condense into ice or snow on the surface. Over time, the night side might even develop vast frozen plains, where water, carbon dioxide, or other gases solidify and form shimmering frost landscapes. Between these two extreme halves exists a narrow twilight zone, the thin strip of land that separates light from darkness. This is called the Terminator Line, and it could be the most important region on the entire planet. Here, temperatures might balance between hot and cold, warm enough to melt ice and support liquid water, but cool enough to prevent evaporation. It's in this band of endless sunset that scientists believe life might be possible. If you stood in this twilight region, the scene would be unlike anything on Earth. The star would hover low on the horizon, locked in permanent sunset, painting the sky in shades of deep orange, red, and violet. To one side, the world would fade into light, bright, hazy, and hot. To the other, the landscape would vanish into frozen darkness. Winds would constantly rush between the two sides, as air from the hot, bright hemisphere tries to fill the vacuum of the cold, dark one. These winds could create powerful weather systems that wrap around the planet endlessly. Despite how strange it sounds, this kind of world could still be stable, perhaps even habitable. If TRAPPIST-1e has a thick enough atmosphere, it could help spread heat evenly around the globe, softening the extremes of temperature. Computer models suggest that under the right conditions, oceans could form in the twilight zone, their surfaces glinting faintly under the crimson sky. So when we call TRAPPIST-1e the planet that never turns, we're describing more than its rotation. We're describing a world frozen in a cosmic balance. One side bathed forever in light, the other in darkness, and between them, a fragile ring of life caught in eternal dusk. It's a planet of opposites day and night, fire and ice locked together in perfect silent harmony. Every world has a personality, and for TRAPPIST-1e, that personality is wrapped in mystery and possibility. Unlike the gas giants or scorched barren rocks elsewhere in the galaxy, TRAPPIST-1e feels alive, not because we've seen life there, but because its nature seems to invite it. Scientists have long looked at this planet and wondered, could someone or something breathe there? To answer that, we first have to understand what the planet itself is made of. TRAPPIST-1e is a rocky planet, much like Earth. It's almost the same size, just slightly smaller, and its density is strikingly similar. This tells astronomers something important. It likely has a metallic iron core surrounded by a silicate mantle and rocky crust, just as Earth does. That makes it one of the few exoplanets we know that truly resembles our own world in structure. This similarity also means it might have volcanic activity deep beneath its surface. Volcanoes could release gases such as carbon dioxide, nitrogen, and water vapor into the atmosphere, exactly the kind of chemical mix that helped Earth form oceans and air billions of years ago. If TRAPPIST-1e has those same processes, its atmosphere might not only exist but could be stable and protective, sheltering the surface from the harsh radiation of its red dwarf star. Now, TRAPPIST-1e's star, though faint, is still a volatile red dwarf. Red dwarfs often release powerful bursts of radiation called stellar flares. On a nearby planet, those flares could strip away an atmosphere unless something defends it. That's where TRAPPIST-1e's magnetic field could come in. Because the planet's density suggests a molten metallic core, it may generate a magnetic field strong enough to deflect dangerous particles, just like Earth's magnetic shield protects us from the solar wind. If that's true, TRAPPIST-1e could be one of the rare, small worlds able to hold on to its air for billions of years. But what would that air be like? If you could stand there on the surface under the glow of a motionless red sun, you might breathe a thin but breathable mix of gases. Scientists believe the atmosphere, if it exists, could be made mostly of nitrogen, carbon dioxide, and perhaps water vapor or oxygen if photosynthetic life ever developed. It might feel cooler and denser, with winds moving constantly between the bright and dark sides of the planet. The sky, however, would not be blue. The faint red light from TRAPPIST-1 would scatter differently in the atmosphere, giving the air a deep coppery hue like an endless sunset. Clouds might form high above, tinted gold and crimson, drifting slowly in the planet's steady light. Every breath, every gust of wind would remind you that you're standing under an alien sun. If the atmosphere is rich enough, it could also regulate temperatures between the two hemispheres, carrying heat from the day side into the night side, softening the extremes of both. This circulation might create vast jet streams, constant winds, and perhaps even rainfall near the twilight zone. Water vapor rising from the warm regions could condense and fall as rain along the cooler boundary, feeding rivers and lakes that shimmer faintly under the red light. To scientists, all this makes TRAPPIST-1e more than just another exoplanet. It's a biological puzzle. It might have all the key ingredients for life: a solid surface, a stable atmosphere, protection from radiation, and temperatures that allow liquid water. But until we can study its air directly, until a telescope captures the fingerprints of those gases through spectroscopy, we can only imagine. So for now, TRAPPIST-1e remains a breathable mystery, a planet that tempts us with its familiar size and shape, yet hides its truth behind a veil of crimson clouds. It could be barren rock, or it could be something far greater, a living, breathing world quietly turning in the shadow of a dim red star. If there's one thing that captures humanity's imagination more than anything else, it's the idea of water, that shimmering, life-giving element that turns barren worlds into living ones. And on TRAPPIST-1e, that idea feels tantalizingly close. TRAPPIST-1e sits in the habitable zone of its star, the narrow band where heat from the red dwarf is just right for liquid water to exist. Too close, and oceans would boil into steam. Too far, and they'd freeze into glaciers. TRAPPIST-1e lies right in the middle, in that delicate cosmic balance where water can flow, pool, and sparkle under alien skies. But what would those oceans be like? Because the planet orbits so close to its star, the light falling on it is far dimmer than sunlight on Earth, yet it's rich in red and infrared wavelengths, giving everything a warm, copper-red glow. If TRAPPIST-1e truly has seas, they wouldn't look blue, they might shine like liquid ruby, reflecting the reddish star above. Waves would roll beneath a sky of permanent sunset, the horizon glowing faintly even at night. Scientists have modeled several possible versions of TRAPPIST-1e. In one scenario, it's a water-rich world with oceans covering most of its surface, perhaps kilometers deep. These oceans might swirl with slow, powerful tides pulled by the gravity of the nearby star and the neighboring TRAPPIST planets. The tides could generate internal heat through friction in the planet's crust, helping to keep the water liquid even on the darker side. In another model, TRAPPIST-1e might be more like Earth, a mix of continents, oceans, and polar ice caps. Clouds could drift between day and night, carrying rain that feeds rivers across the twilight band. The terminator zone, the region between light and darkness, might host vast ring-shaped seas that encircle the planet, where ice from the night side melts and flows toward the day side, creating an endless cycle of water, vapor, and rain. Even if TRAPPIST-1e has only patches of liquid water, underground aquifers, or isolated lakes, that would still be remarkable. Liquid water means chemistry can happen. Molecules can mix, react, and evolve. It's in that liquid cradle that life as we know it is born. And just imagine the view from above. If you stood on a mountain near the twilight zone, you might look across a crimson sea stretching toward the horizon. The water would shimmer under the dim red light of TRAPPIST-1, with the silhouettes of the other TRAPPIST planets faintly visible in the sky, each glowing like a pale orb, close enough to seem within reach. The air might feel cool, heavy with mist, and the sound of slow, rhythmic waves could echo endlessly, as if time itself had slowed down. The idea of oceans on TRAPPIST-1e isn't just poetic, it's scientifically plausible. The planet's density and reflected light hint that it may once have had, or still has, significant amounts of water. And if oceans truly exist, they could serve as natural shields, absorbing radiation, stabilizing the planet's temperature, and nurturing chemistry that could lead to life. So when scientists speak of TRAPPIST-1e, they don't just speak of rock and gas, they speak of hope. Because where there is water, there is potential. And somewhere beneath that eternal sunset and those crimson waves, something may already be stirring quiet, unseen, alive. Imagine standing on the surface of TRAPPIST-1e. Above you, the star TRAPPIST-1 hangs motionless in the sky, a glowing red sun that never rises, never sets. It's larger than our sun would appear from Earth, but dimmer. Its light soft, bathing the landscape in an eternal crimson twilight. Shadows stretch endlessly, unmoving, as though time itself has stopped. But while the sky seems frozen, the world beneath your feet is alive. The planet's surface could be carved by mountains, canyons, and ancient riverbeds, all shaped by the slow hand of alien weather. On the day side, the ground may shimmer with heat, cracked and dry, with iron-rich dust giving the soil a deep rust color. Winds constantly flow from this bright hemisphere toward the night-side colossal atmospheric rivers that race across the terminator zone, carrying moisture, heat, and storms. Cross into the twilight band, and the scene transforms. Here the temperatures balance in delicate harmony. You might find lakes or shallow seas reflecting the unmoving red sun. The air would be cool, dense, and calm compared to the roaring winds on either side. If clouds drift overhead, they would glow with copper and gold edges, eternal clouds lit by an unchanging star. Farther into the dark hemisphere, the landscape plunges into silence. Here, ice reigns. The surface could be covered by glaciers miles thick stretching toward the planet's frozen heart. Beneath that ice, however, there might still be warmth, geothermal energy from the core, or tidal heating caused by gravitational tugs from TRAPPIST-1's other planets. These hidden heat sources could melt pockets of liquid water under the frozen crust subsurface oceans, like the ones beneath Europa's ice in our own solar system. And there, in that hidden warmth, life might find a way to survive, perhaps in microbial colonies beneath the ice, feeding on minerals or chemical energy, perhaps drifting in dark waters untouched by light in a world that never knows day or night. TRAPPIST-1e's stillness is an illusion. Though the star doesn't move across its sky, the planet itself is alive with motion and contrast, scorching deserts on one side, glaciers on the other, and a twilight realm that ties them together. The air churns, the ground shifts, and every atom hums in quiet balance between extremes. If humans ever stood there, it would feel both familiar and alien gravity nearly identical to Earth's. A solid surface beneath your boots, yet a sky forever frozen in one moment. The red light would stretch every shadow, making the world feel like an endless sunset. You'd see the neighboring TRAPPIST worlds hanging overhead, huge and bright like moons close enough to touch. They would move slowly, gliding across the sky as days' orbits passed in just 6 Earth days. To live there would mean existing in permanent time, no sunrise, no sunset, no sense of morning or night. Clocks would mean nothing. Life would adapt to the rhythm of wind and warmth instead of light and dark. This is what scientists mean when they say TRAPPIST-1e is frozen in time. It's a paradox, a world that never turns, yet never stops moving. A planet locked in light and shadow, yet pulsing with invisible energy. In that stillness there's beauty. In that balance there's life's greatest possibility. Across the vast black ocean of space there are countless stars, countless planets, each one silent, distant, unreachable. And yet, TRAPPIST-1e stands out like a whisper of hope. It is more than a dot on a telescope image. It's a mirror a reflection of what Earth might be like if it were born around another kind of sun. When astronomers first detected TRAPPIST-1e, it wasn't just another number on a chart. It was proof that Earth-sized worlds are not rare. For the first time, we found a system where 7 rocky planets, some possibly covered in oceans, some baked by light, some frozen in shadow orbit, a single small star. And one of them, TRAPPIST-1e, lies right where life could bloom. That discovery changed everything. It told us that the conditions for life might not be unique to Earth, that the universe could be filled with planets where water flows, clouds drift, and skies glow under alien suns. TRAPPIST-1e became a symbol of possibility, a sign that we might not be alone. But its importance isn't only emotional, it's scientific. Because TRAPPIST-1e is so close to us, just about 40 light years away, we can study it with our most advanced telescopes. Instruments like the James Webb Space Telescope can analyze the faint light passing through its atmosphere, breaking it down into colors to reveal what gases are present. From those patterns, scientists can search for the fingerprints of life-related molecules: oxygen, methane, carbon dioxide, even water vapor. If those signs appear, it would be the first time in human history we've detected the chemical breath of another world. TRAPPIST-1e also teaches us about resilience. Its star, TRAPPIST-1, is tiny and unstable compared to our Sun day. It flares, it cools, it burns unevenly, and yet if TRAPPIST-1e still holds on to an atmosphere, if it has survived billions of years in that environment, then it shows us that life might endure under conditions we once thought impossible. Philosophically, it pushes us to imagine what home really means. What if, one day, humans looked up from the surface of TRAPPIST, TRAPPIST-1e, and called that red sky home? What if civilization someday spread across the galaxy carrying pieces of Earth's story to worlds like this one? TRAPPIST-1e reminds us that the universe is not empty, it's alive with potential, waiting for discovery. So when scientists, dreamers, and explorers gaze toward the faint red star in the constellation Aquarius, they see more than a planet. They see a promise that our search for life is not in vain, a promise that somewhere out there, another sky may already shelter another kind of Earth. TRAPPIST-1e matters, the narrator would say softly, because it reminds us that the universe has room for infinite beginnings. Far beyond the reach of our spacecraft, in the quiet depths of the universe, the faint red glow of TRAPPIST-1 flickers like a dying ember against the dark. Around this small star, 7 tiny worlds drift in perfect rhythm, their orbits delicate and precise, each held in the invisible pull of gravity. Among them, TRAPPIST-1e stands out, a world balanced between shadow and light, where the star's dim warmth might still cradle oceans and winds. This distant planet, orbiting 40 light-years from Earth, moves through a sky that never changes. Its sun hangs motionless above the horizon, casting an endless copper glow across a landscape caught between fire and frost. To imagine standing there is to imagine a world both alien and familiar. Red sunlight spilling across quiet seas, clouds painted gold and rust drifting above a horizon that never fades, and winds whispering softly between the bright and dark sides of the planet. Time itself seems to pause on TRAPPIST-1e. The star never rises or sets. The days and nights never trade places. Yet within this stillness there is motion, a breath, a rhythm, a fragile balance that mirrors the nature of life itself. The planet reminds us that existence is born in equilibrium, between chaos and calm, between heat and cold, between curiosity and fear. Above its crimson skies, the other TRAPPIST worlds glow faintly, enormous and silent, each one a companion in orbit turning slowly through the endless night. TRAPPIST-1e is more than a planet. It is a story written in starlight. It speaks of endurance, of mystery, and of the human desire to understand the unknown. It shows us that even in the farthest reaches of space, Worlds can form under impossible conditions, carrying within them the same potential that once sparked life on Earth. It is a reminder that our universe is not barren, it is alive with possibility, filled with unseen homes waiting to be discovered. Somewhere beneath that unmoving red sun, a quiet world waits, its silence echoing through the cosmos. And as long as we keep searching, listening, and dreaming, we will never truly be alone. Beneath the red glow of TRAPPIST, one's eternal twilight, TRAPPIST-1e may be far from silent. Though we cannot hear it, the planet could hum with hidden activity, an orchestra of shifting tectonic plates, churning molten layers, and whispering winds that sweep endlessly across its surface. Scientists believe that, like Earth, this world might have a molten iron core creating a magnetic shield that protects it from the violent flares of its star. If true, that invisible barrier could be the single reason life might survive here, a guardian against cosmic radiation in a system where most worlds are stripped bare. Imagine standing on the thin line between day and night, where one side of the horizon burns in red gold light while the other sinks into an infinite darkness. The temperature difference could drive mighty winds that roar at hundreds of kilometers per hour, swirling clouds of vapor across the planet's skies. Rain might fall not in drops but in mist, sparkling under the crimson sun like dust made of rubies. In that narrow band of perpetual dusk, oceans could shimmer quietly, their surfaces reflecting a sun that never moves. And somewhere beneath those waters, if they exist, chemistry could be at work. Molecules could be combining, splitting, and reforming in endless experiments of creation. Perhaps there are currents that carry the raw ingredients of life. Just as Earth's ancient tides once did billions of years ago, it is this possibility that life may have taken its first fragile breath under an alien sky that keeps scientists searching. TRAPPIST-1e challenges our imagination. It's a planet that lives in extremes, yet somehow balances perfectly between them. Its world is both harsh and delicate, frozen and fiery, still and alive. It is a portrait of survival, a reminder that even in the smallest corner of the cosmos, the universe may be writing stories of life in languages we have yet to learn. What if the next discovery changes everything we know about life beyond Earth? Stay curious and subscribe for more incredible space stories just like this one. The adventure is only beginning.